In this video, we're going to look at break-even analysis. So we're going to be looking at cost, revenue, and profit. Let's begin with the cost function. The cost function, C of Q, gives the total cost of producing a quantity Q of some product, of some good. So in this case, the cost is a function of the quantity. So we input the quantity to get out the cost. So here we have fixed cost, and those are the costs that we incur regardless of the number of items produced. So this is the value associated with the cost when the number of items produced is 0. Now variable costs are those costs which depend upon how many units are actually produced. And so this value is the increase in cost per additional item produced. So if we consider this, then C of Q, right, is equal to M times Q plus B. So this is kind of our simple linear equation where B represents the intercept, or in this case, the fixed costs, and M, the slope, represents the variable cost per item. Going on to the revenue function R of Q gives the total revenue received from selling a quantity Q of some good. So in this case, the revenue also is a function of the quantity. So the input is the quantity, the output is the revenue. So revenue, in generic terms, is always going to be price times quantity. And if the price is the same for everybody and doesn't change, this can be a constant, and so you just have that being the slope, P times Q. The profit function, right, we're going to represent this as P of Q, gives the total profit gained from producing and selling a particular quantity Q of some good. So again, we've represented profit as a function of the quantity. And so if you think about this, the profit is simply the revenue minus the cost. So remember, profit is equal to the revenue, how much money we receive, minus the cost, how much money we spent in producing that number of items. So here we're going to consider the break-even point. The break-even point for a company is the point where the profit equals 0 and the revenue equals the cost. So let's look at an example here. Let's consider selling some t-shirts. So let's look at some fixed cost. So to get started, we need to buy a printer and a press. All right. We also need a cheap computer. And so we're going to consider $500 in fixed costs. All right. Now variable cost. So for every shirt that I sell, I'm going to have some printing cost and a shirt that I have to use to produce it. So I'm going to look at variable cost of about $15 per shirt. So with fixed cost of $500 and a variable cost of $15 per shirt, what I have here is a total cost function of 15Q plus 500. So fixed cost is the intercept, $500. The variable cost, the slope, is $15 per shirt produced. Now let's consider revenue. So let's consider selling it at a price of $25 per shirt. So my revenue function, R of Q, would be equal to 25Q, where I just multiply the price, $25, times the quantity, the number of shirts sold, Q. So the break-even point would be when the revenue actually equals the cost. And so what I need to do is solve the following equation. 25Q, the revenue, equals 15Q plus 500, the cost. So to illustrate this in a graph, here I have in red the cost function, in blue the revenue function, and what I'll notice is the point of intersection, the quantity at which the cost and the revenue are equal, right, is 50 shirts. So at 50 shirts sold and produced, the revenue and the cost both would be $1,250. And so at this point, I would break even. The revenue, the money I've received, is exactly the same as the cost it took to produce 50 t-shirts. Now the profit function, remember, is revenue minus cost. So if I were to find the actual profit function, I could just subtract the cost function from the revenue, and I would end up with 10Q minus 500. So remember, the break-even point is when the profit is equal to 0, or, as we just stated, revenue was equal to cost. So if we consider the profit function and try to solve when the profit would be equal to 0, here we illustrate on the graph, where here I have in green the profit function, 10Q minus 500, and the point at which the profit is equal to 0, the intercept along the quantity axis in this case. So we have 50, 0. So at a production and sales of 50 items, we would actually have a profit of $0. And so consider what we had before for the point of intersection with the cost and the revenue. You get the same quantity at which we're going to break even. Also notice that the gap between the blue and the red is the same as the height of the profit function. So when 50 shirts are produced and sold, the revenue will equal the cost at $1,250, and the profit will equal $0. So in general, we're usually in business to make a profit. So how great a profit do you want? Let's assume that we go into the t-shirt business in order to earn a profit of $6,000 during the summer. So I have a graph here. I have my profit function, and I want to know when my profit will first meet or exceed the $6,000 mark. So here I've put in the profit function at 10Q minus 500, and then I put in the threshold. We want a profit equal to 6,000. So if I graph these two lines and find the point of intersection, I find a point of intersection of 650 shirts at $6,000. So this suggests that if I were to produce and sell 650 shirts, I would end up with a profit of $6,000. So I suppose to meet our goal of $6,000, we better get to work.